All right, following on from our last discussion about templates and the standard templated library, we're going to play with it a little bit here. Let's actually start at the beginning of the talk maybe. So with C++ and the standard template library, we've got things like lists, stacks, queues, vectors, all these sorts of ideas that are provided for us. All we have to do is say, I want a list of ints, I want a list of floats, I want a stack of strings, and it will go ahead, create it for us, and allow us to use the methods that are provided with that templated class. You don't have to worry about doing the explicit instantiation of these things. Again, it's following the basic approach where the blueprint, if you like, is provided in the header file. So when you hash include stack or you hash include list, it's got the blueprints necessary to build the right versions of those particular classes. All right, so the basic idea is when you want to use one of them, you hash include the right library, so list or stack or queue or whatever it might be. You specify, okay, I want a list of ints. If you haven't specified that you're using namespace standard, then you'll need to include the std : in front of this to say that I want a list from the standard namespace. So I want a list, and then you specify the data type of ints, and again, whatever variable name you want. With lists, you can push new items to the front of the list or the back of the list. So you'll see an L push front or L push back. You can remove from the front or the back by using pop front or pop back. You can use front or back as the method names to just get a copy of the front or the back item. You can get rid of all the content with clear. You can figure out how big it is using size. So there's a whole slew of different fairly typical methods implemented for the templated class. And again, just in the beginning, you make sure you specify what kind of data is going into it. Right, for stacks, very much the same idea. I want a stack of strings, or I want a stack of ints, or I want a stack of floats. When you want to push elements in, I think you can actually get away, I don't think you need the back for stacks. I think you can simply get away with s.push or s.pop. And you can look up the top element. I'm not sure how accurate this particular slide is. You might have to take this one with a grain of salt. I think you can get away with s.push to push, s.pop to pop, and s.top to look at the top element. Take this slide with a grain of salt. Let's see. Again, you can look up the size. You can check if it's empty. Right, and all you have to do at the beginning is make sure you specify what you want to stack of. Same idea with queues, right? You can create a queue of some data type. You can push, you can pop, you can check the front or the back, you can check if it's empty. Most of these things are all built off a common underlying type, but you get the idea. And again, all of this is easier than having to write all the code yourself and debug it all yourself, test it all yourself. What we'll get into next is the idea of iterators. So for lots of these data types, lists and queues and whatnot, you might want to be able to walk through all the values in the list, all the elements of the list, or all the values or all the elements in the queue. So iterators are the name that's used for something that allows you to do that walkthrough, to look at one element at a time from front to back, for instance. So for the standard template library, there's a standardized syntax for the iterators, and we'll go through how that works. You create an iterator of the desired type, so an iterator for my stack of ints or whatever it might, or my list of ints. I don't think stacks support iterators. We set it to the first element in your collection. You can use the iterator to grab the current element if you like, and then you can use ++ and - on your iterator to go forward or backward through the collection. So for a list of ints, we set up our list of ints L, and then to declare the iterator, it's going to be the same sort of idea. There should probably be an std in front of the list there. Same sort of idea. You say, for my list of ints, I want an iterator. So it's just the : iterator on the end. So it's a new data type, and then the name you want for your iterator variable. You set it to the front element using the dot begin, so L dot begin in this case. And then if you want to go all the way through to the end, you can say, okay, well, while my iterator is not referring to the one at the end, so while I isn't L dot end, just keep going through it. So I can extract what the current iterator refers to, the current element if you like, using the star and your iterator name. So in this case, if I want to grab the integer that it's referring to right now, I can say int current is, and we'll use this star I to get at it. Do whatever you want with it, and then use your I++, or if you like I minus minus, to move forward and backward from where you are right now. So this is a pretty typical approach to using an iterator to walk through a list. And again, you can do this with most of the standard template library collections. All right, let's take a quick look at, again, some of this in action. So let's take a quick look at possibly the stack, or the use of stacks. So in this case, I've got a stack of strings, and all we're going to do is push a few values in, grab the top element, and pop until it's empty. So we include stack. I'm going to make this a stack of strings, so we'll include string. I'm going to do input and output, so we'll include IOStream. Again, I'll create my stack, or create the a string variable that I'm going to use for this. Create my stack of strings, and you'll notice that I'm having to use the std to refer to stacks and strings, right, the two data types. And I'm just going to call my stack s, and then I'm just going to go through and push a bunch of values into my stack. So I'm just going to go through and say, get the user to enter a bunch of words and push them as I go. And then we'll go through, and just while the stack isn't empty, we'll grab the top element, pop it off, and print it out. So just using s.top to grab it, s.pop to get rid of it from the stack, and then just print out the beast. So again, if I compile this, and hopefully this works, yay! We'll run it. Blah, foo, pick, whatever, bye. So goes through, grabs each of my words. Sorry, I knew it was going to ask for 5, so I just typed 5 words in advance. It's going through, grabbing each of them, pushing them on the stack, and then, well, the stack's not empty, grabbing the top one, printing it out, and popping it off. So again, you can use stacks fairly easily. Same idea for our list. Oops. So in this case, we'll actually play with the iterators, since we've got iterators for lists. So I'm going to create a list of ints. I'm going to push a bunch of them on, and I'm just going to show using, push back and push front here. So we'll push 23 on the back, 17 behind that, 1 in front of them, and then 2 in front of that. So this should probably come out, 2 should be in front, then 1, then 23, then 17, I think. So again, you can push on either end. And all we're going to do is set up an iterator to walk through the current contents of the list. So again, you specify that I want an iterator for a list of ints, and I'm just going to call my iterator it. I set it to refer to the front element of the list, and while it's not referring to the back element, I'll grab whatever it's referring to now and print it out and move on to the next one. So I grab the current item, I print it out, and I move on to the next one. So hopefully this compiles. Yay! And we try running it. And so again, it's here's our iterator just cycling through the elements themselves. So iterators, again, they're very handy. They're supported by lots of the different STL collections. There was one more I wanted to point out there. Our list of lists. So in this case, just to look at a bit more twisted syntax. So we've seen the idea of creating, a list of ints or whatever it might be and pushing things into it. What I'm going to do here is create a list of lists. In this case, a list of lists of ints. So LL is a list whose elements are lists of ints. So I start off by pushing that other list of my list of ints here into my list of lists of ints. So as long as you're willing to wade through the syntax for the declaration, so you just see that, again, the data type I'm specifying in there is that this thing is made up of lists of ints, it'll all work out. And again, if you want to create an iterator for this, it's just a matter of getting your syntax right. I want, for my list of the lists of ints, I want an iterator, and then create that. So again, as long as you weave through the syntax okay, it should work out fine. All right, highly recommend the use of the standard template library. Highly recommend the use of the iterators provided in them. It is something that's worth learning. I believe I'll get you to do that as part of the project at some point, one of our labs coming up. But again, this is something that can make your life a lot easier if you get used to it now. All right, we'll leave it there.